Hello and welcome. For those who decided to into this video, thank you. This is my first time making one of these, so we're just gonna go with the flow. So I am a nursing student, and a lot of the things that people have problem with is dosage calc. So I'm trying to make this at least a 2 to 3 part series, just going through step by step on how to approach these problems, because medication math is not the easiest. So with this one, we're just going to start with the basics of solving for volume of a dosage calc problem, and then just go in the reverse. So yeah, we're just going to get ahead and get started. So the first thing I want to go over is like how to solve for different methods. So everybody has their own way of doing math. These are the two that I found helpful, so I'm going to share them with you guys. Well, one of the most common ones that people normally use is the desired over half. So the equation will be D over H times Q equals B. So D is your desired. So desired means that's the dosage that the physician or the provider has ordered for the medication. Your H is your half. So that means that is the dosage that is given on the medication label. So say it's 5 mLs per 1 gram. That would be your half. The quantity, which is Q. Yeah, so Q stands for quantity. And what quantity basically means is what the dose is actually in. So whether it be a tablet, a capsule, or an mLs, that would be your quantity. That would be what your medication is in. And then V, which is volume. So that would be how the med would be administered. So like if it was an IM injection, you're going to look for the volume of that IM administration. So that would be your volume. The second way to go about it would be dimensional analysis. So I'm going to use the same letters just so it kind of makes sense. And we're just going to go from there. So for dimensional analysis, for those who aren't familiar with the dimensional analysis, it's mainly used for like chemistry problems. So especially like those hard titration equations, stuff like that, that's where dimensional analysis come in. It can be used the exact same way for dosage calc. So I'm gonna just show you the setup. So going about dimensional analysis, you're gonna start off with Q, which is that quantity. So it will be Q equals, and then the whatever is on the left side of the equation, that would be in that numerator up top. And then at the bottom of the equation would be your half. And then you're going to multiply by the desired, which is up top, and you're going to put that over 1. So to make it easier, we're going to do it this way. Say you're solving for mLs, right? You're going to equal that to ml over, say you're solving for milligrams, so you put milligrams at the bottom. Then you're going to multiply that by the milligrams that you desire, so it'll be the second part of the milligram. You're going to put that over 1. So in dimensional analysis, when you're multiplying, you're going to multiply across. So the mg is going to cancel, the mg is going to cancel, so that way you're going to end up with the ml that you were looking for. It may sound a little confusing at first, but it should start clicking a little more once we get into these type of problems. So yeah, so we got desired over half, which is D over H times Q equals V. And then we have the dimensional analysis. So we're going to go ahead and get into our first problem. So our first problem is, what is the volume required for an injection if 500 milligrams are ordered and stock ampoules contains 250 milligrams per ml? So we're going to go the desired over half route first, just so you can see what it looks like. So your desired would be this 500 milligrams. So you would do 500 milligrams. And then your half would be this 250. So it would be over 250 milligrams. And then your quantity, which is that Q that we're solving for, that quantity would be that 1 ml, because it is tacked on this, because that would be the quantity that you're looking for. So it'll be over times 1 ml. And then all you're going to do is solve. So all you're going to do is take your 500 and divide it by 250. So you should get 2, and then the milligrams will cancel each other out. So you multiply that by that 1 ml, and then you should get 2 mLs. Oops, that circle is a little too big. So 2 mLs should be your answer. Now, going the dimensional analysis route, have the same exact numbers. So you're looking for ml. So you're going to put ml equals, and since ml is what you're solving for, that's going to be your numerator. So it'll be 1 ml up top. And then same kind of situation with the desired over half, it's tacked on to that 250 milligrams. So that 250 milligram will be your denominator. And then going to the other side of the problem, you're going to put 500 milligrams up top over 1, because that 500 is not tacked onto anything. It's just 500 milligrams by itself. But because it is a ratio, we just put it over 1, so just so it's not an empty space. If you wanted just to do the 1 ml time divided by 250, and then just time the 500 by itself, that works too. I just like it this way, because just so it's kind of stacked and it's a little cleaner that way. So when you cross multiply, these are going to cancel each other out. So that milligram is going to cancel. So then the only thing that you have left is the ml. So you're going to multiply these, and you're going to multiply this. So you would end up with ml equals 500 over 250. And that will get you 2 mLs. So same thing, you should, no matter what method you choose, you should get the same answer no matter what route you go. So that's the first problem. We got a couple more to do just so you get the hang of it. All right, question number 2. What is the volume required for an injection if 600 milligrams are ordered and stock ampoules contain 350 mLs? So we're going to go to D over H times Q equals V first. So that your desired is that 600. So you're going to put 600 milligrams. And then your half is at 350. So 350 milligrams will be at the bottom. And then you're going to multiply that by the 1 ml. So I'm going to do 600 divided by 350. And then you should get a few decimals running. So it'll be 1.7142. I'm just stop it right there. times 1 ml. I always cross them out just so I can just keep tabs of my own. But so typically with dosages, they go by the first decimal place. So you should remember your rounding rule. So if it's above 5, you round up. If it's 4 and under, you round down. So the second decimal place, which is 1. So since it's that 1, we're just gonna keep it the same. So it'll be 1.7 mLs for this dose. Now we're gonna go to dimensional analysis. So looking for mLs. So we have 1 ml over 350 milligrams times 600 milligrams over 1. Cross those suckers out. And then all you're going to do is multiply that 600 by the 350 like we did the other ones. So 600 divided by 350. Again, you should get 1.7142 mLs. So as long as you round, you should get 1.7 mLs. And there you go. Question number 3. What is the volume required for an injection of 750 milligrams ordered in the stock ampoules containing 200 milligrams per ml? So I'm going to go desired over half again. Just going to keep rocking and rolling here. So I'm going to do that 750 milligrams over that 200. Multiply that by 1 ml. Cancel those babies out. We're going to go 750 divided by 200. 3.75. So we got 3.75 times 1 ml. And since we got that 5, we're going to round up. So you should get 3.6 mLs for this dose. All right, we're going to go dimensional analysis route. So you got mLs. We got 1 ml over 200 milligrams. And then you're going to do that and multiply. And then on the other side, got 750 over 1. Cancel those babies out. So then you got 750 divided by 200. And then you should get 3.75. Round up, you should get 3. My mistake. That's supposed to be 3.8, not 3.6. That is my apology. You should get 3.8 milligrams. I'm going to change that so that reflects what I found. So yeah, that was my mistake. Yeah, you should get 3.8 mLs because that 5 you're going to round up. So you should get 3.8 no matter which one you choose. Okay, so now we're going to get into where we have numbers along, let's attach to that ml now. So a dose of 2 grams of medication has been ordered for a patient. The medication comes in 4 grams over 0.4 mLs. What volume will you give for this patient? The wording sounds a little bit off, but you're literally just solving the exact same way like we did the other ones. So I'm going to do the desired over half one first, like the same method we've been going through. So your desired is at 2 grams. That half, which is this, is that 4 grams. And then you have 0.4 mLs. Cross those G's out. And then you're going to do 2 divided by 4. You should get 0.5. You're going to multiply that by 0.4. You should get 0.2. So you should get 0.2 mLs for this one. Now dimensional analysis. So we're solving for milligrams. So this time, instead of just being 1 ml, since we now have a quantity right here, I'm going to do 0.4 mLs over 4 grams, again, because it's a ratio. So you want that ratio to add up. And then you're going to multiply that by 2 grams over 1. Again, cross those out. Now, since these are crossed out, we could just multiply across. So, we got ml equals, so we got 0.4 times 2, that's 0.8. And you take that ml on there because we still have that. And then 4 times 1, that's just 4. So 0.8 divided by 4, you should get 0.2 mLs. So no matter which way you go, you should still end up with the exact same answer like you did the last time. All right, next one. A dose of 4,500 milligrams of medication has been ordered for a patient. The medication comes in 5 grams per 0.3 mLs. What volume will you give the patient? So I'm going to do the desired over half one method again, just so you just keep seeing, the thought process behind it. So your desired is that 45,000. Just going to erase that M. That looks a little weird. That 4,500, milligrams, and that half is 5 grams. Now, the only thing is, because we do have milligrams and grams, this we can't do because you have to convert first. So anytime you have a problem where you have to convert methods, for the desired over half method, you have to convert first. So we're going to erase this. So for reference, and I'm going to put this in red. So 1 gram equals 1,000 milligrams. So this is going to be the conversion that we're going to be using because we do have 1 gram in our problem. So if 1 gram equals 1,000 milligrams, then that means 5 grams equals 5,000 milligrams. And this was what we will be using in our problem. And we're only doing this for dimensional analysis. I will show you the flip side of it we're only doing this for the desired over half. Now, you could do the same thing for dimensional analysis, but it'll be a little smoother. So going back to desired over half. So we already converted. So we're going to do 450 milligrams over 5,000 milligrams. And then you're going to multiply that by 0.3 ml. So once you convert it, you still go about it the same way. I'm going to cross those babies out. And then you're going to do 4,500 divided by 5,000. You should get 0.9. I'm going to times that by the 0.3 ml that you still have. And then you should get 0.27. Now we're going to round that up. So in reality, you should get 0.3 ml. And then plus, depending on your medication administration, they may take the 0.27, but in most cases, for school purposes, they want you to round up to that one decimal place. But again, check in with your instructor to see what they prefer. But in the case where you only have 2, I typically just round up to that one decimal place. It just makes it a whole lot easier. All right, now for the dimensional analysis part, we're going to set it up the same way. So we got that ml. So we got 0.3 mLs. And then we have the 5 grams times 45,000 milligrams. If it's okay with y'all, I'm gonna just shift these over just a wee bit because I'm gonna need a little more room. There we go. All right, so we got milligram over, ml. So 0.3 ml over 5 grams times 4,500 milligrams over 1. And then where that dimensional analysis come in. So you got to set it up like a ratio so that way all sides cancel each other out. So I'm going to multiply that by 1 gram over 1,000 milligrams. So that way when you multiply this gram down here and that gram on the other side is going to cancel. This milligram, that milligram is going to cancel. So everything cancels each other out. And then you just multiply across. So you got 0.3 times 4,500. And you should get 1,350. And then you should get 0.5 times 1,000. And you should get 500. Divide by those two. Okay, so let me see what I went wrong at here. Oh no, that's right. I apologize. I added one more zero that it should have been. So, in case you were wondering about that brain part, yeah, it's supposed to be 5,000. Sorry about that long pause that I took. So, yeah, so 1,350 divided by 5,000, you should get 0.27 mLs. Round up, 3 mLs. So, that was me. Sorry about that very, very long pause. I just had a brain fart, didn't realize what I was doing. So, yeah. So, if you're going the desired over half route and you have to convert your whichever one, whether it be your desired or your half, you have to convert first. Typically, if you're going to convert, you want to convert whatever it reflects. It don't matter which way you convert, you should get the same way either way. For dimensional analysis, all you have to do is tack on that ratio at the end of your problem. Everything will cancel each other out. You should get the exact same thing. So, yeah. So the conversion part is going to be a little antsy, but with a little more practice, you should be able to get the hang of it. All right, so we got another one here. So I'm not going to continue writing the ratio equation. If you guys got to roll it to the side, perfect. We're just going to keep rocking and rolling. So question number 6, we have a dose of 3,500 milligrams of a medication that's been ordered for a patient. The medication comes at 5 grams per 2 mLs. What is the volume you would give this patient? So I'm going to go desired over half. Now, we're going to convert first so that 5 grams will equal 5,000 milligrams. So we're going to go 3,500 divided by 5,000 times 2 mLs. So 3,500 divided by 5,000 should get 0.7 times 2 should get 1.4 mLs. Dimensional analysis, we're going to go the exact same way. Going to go ml. So you have 2 ml up top, 5 grams on bottom. Got that 3,500 on the other side. Make sure you always tack on those volumes and those ratios. Well, my bad, those units, because you always want to keep track of units, so that way you know exactly what you're doing. And then you're going to multiply that by that 1 gram over 1,000 milligrams. Cancel everything out. So you're going to go 2 times 3,500. Should get 7,000. Over that 5,000. And then you should end up with 1.4. So yeah, no matter which way you go, you should always end up with the exact same answer either way. All right, part 2 of this, we're going to solve for the base. So the base meaning whatever unit you're solving for, whether it be like the grams or the milligrams. So you're only going to be given 2 instead of, the 1. It sounds a little confusing, but it'll make sense as we go along. So how many mLs? So the question is, how many milligrams per ml will be infused for a solution of 350 milligrams of a medication in a 100 ml of saline, round to the nearest decimal. I am sorry for butchering all of that. Did not mean to. All right, so all you're going to be doing is solving for the ml. So for this one, I'm only going to just go one way, just so it'll make it easier for everyone to see. So in this case, you only are given just one of the milligrams. So you're just going to be solving for the other one, essentially. So we're going to set up the equation this way. So we're going to go, and I'm going to write this in red just so it's a little easier. So I'm going to just do X up top just because it's a little easier on the eyes for me. You go write down the milligram, whatever the case may be. So we got the X, and then, no, I take that back. I apologize. So that 350 milligram what am I doing? I apologize. Sorry for the brain part. It's been a long day, so bear with me here. So milligrams per ml. So you got X over 350 milligrams. And then you got 100 mLs already. So you're going to put that baby over to the side. Now all you're going to do with these two numbers right here, you are going to divide. So you're just going to do 350 divided by 100. and you get 3.5 milligrams. And that should be your final answer. Because all you're doing is just solving for how many milligrams that you need. And it says round to the nearest to one decimal place. The decimal place is already 3.5. I'm just going to leave it at that. Next one. How many milligrams per ml would be infused for a solution of 400 milligrams of a medication and 300 milliliters of saline? So we got X over 400 milligrams times 300 mLs. I'm going to divide those two. So you got 400 divided by 300. And you get 1.33 repeating. So it just says round to the one decimal place. So since it's below 4, you're just going to round down. So your answer should be 1.3 milligrams. And that should be your final answer. All right. So, and I believe this is the last one. So, how many milligrams per ml would be infused for a solution of 550 milligrams of a medication and 200 mLs of saline? And you're going to round to the one place. So, got X over 550 milligrams times the 200 ml. Gonna divide those two. So 550 divided by 200, get 2.75. Gonna round up, you get 2.8 milligrams. And that should be your final answer. All right, I hope this video was very informational. And thank you for bearing with me. This is my first time actually doing one of these teaching videos, so I appreciate those who bared with me and my numerous brain farts. But I will continue to do content like this, and just give me a like, thumbs up, subscribe, comment, and share it. Please share it, because this is not easy by long